Alright, so we're going to look at some Pythagorean identities, and we're going to be using these to simplify some expressions. So this is a pretty difficult concept. It's pretty advanced. You have to have just regular math skills, and then you have to know some stuff about trig. So our learning target is I can use Pythagorean identities to simplify expressions. So here's the first thing I want you to see. Okay, so let's say that this is A, and this is B, and this is C. Alright, and then let's think about the unit circle, which kind of looks like this. Remember that if I had went over this far, that would be my x-coordinate. And if I went up this far, that would be my y-coordinate. And the radius of the unit circle is always 1. And then also recall that when we talked about the unit circle, we said the cosine the cosine of the angle was always equal to x, and we said the sine of the angle is always equal to y. So I'm going to use that over here. So for A, I'm going to really call this the cosine of x. And for B, I'm going to call it the sine of x, and C is going to be 1. So we're putting back together stuff we learned in middle school, Pythagorean theorem, stuff we learned in Math 2 and Math 3, trig, unit circle, and then we're just going to use that to do some stuff. So remember, Pythagorean theorem says a squared plus b squared equals c squared. So for me, I have cosine squared plus sine squared equals 1 squared to 1. So right here is a big Pythagorean identity. From this identity, we can do some other things. So we can take this identity, and let's say we just divide everything by cosine. Let's divide it by cosine squared. Alright, so from that identity, so cosine squared divided by cosine squared will just be 1. This is another thing that we should remember. Tangent is equal to sine divided by cosine. So sine squared divided by cosine squared will be tangent squared. Alright, and then another thing that we should know is that secant is the reciprocal of cosine. So if I had 1 over cosine squared, let me do that a different color. Would be the same thing as secant squared. Alright, so right there is another big trig identity that we'll use. If I had taken that original trig identity that we talked about, and let's say I divided everything by sine squared. Sine squared. Cosine divided by sine is the same thing as cotangent. Sine divided by sine would be 1, and the reciprocal of sine is cosecant. So there's another trig identity, and then you can rearrange it. So none of this you have to actually know. I just want you to understand that they're getting all of this from just small things like Pythagorean theorem, unit circle stuff, reciprocal identities, lots of things we've talked about. So I'm going to write 9 Pythagorean identities that you're going to need to know and understand. And just know that all of this comes from the Pythagorean theorem, which is why they're called the Pythagorean identities. Okay, so here are the 9 Pythagorean identities. You need to write them down. We're going to be using them. Just know that they come from the Pythagorean theorem. They're not just made up. They may not be important to your life, but they are in someone's. When I was a math major, I have notebooks and notebooks filled with me proving that these are true. Sometimes I still get nightmares about it, but it's cool. Okay. So pause the video if you still need more time and write these down, and then we're going to use them to do some simplifying. Alright. Okay. So, simplify each identity using the Pythagorean identities. So, first thing I need you to understand is we have an identity that states something about this up here. So if you go back and look at that very first one. Cosine squared plus sine squared is equal to 1. So I can replace that whole stuff up top with the number 1. Alright. So then, if we remember the things we know about reciprocals, remember that 1 over secant would be the same thing as the cosine. So this would be the most simplified form I could get that expression. Okay, so you had to know stuff about the Pythagorean identities, and then you had to know stuff about previous lessons about reciprocal identities. So down at the bottom, I'm going to write the reciprocal identities, and so you know what I'm talking about. Okay, so down at the bottom are those reciprocal identities that we talked about in a previous lesson that we're coming up and using again. Alright, so if I look at example 2, one of these is a Pythagorean identity. I'm going to highlight. So now I want you to go back to your Pythagorean identity chart and see if you can find the one we would use for this. So cosine squared is the same thing as 1 minus sine squared. So I'm going to replace that part that I just highlighted in yellow with cosine squared. Okay, so I have secant squared on the outside. I used a Pythagorean identity to replace that. Okay, now I'm going to use those reciprocal identities down at the bottom. So secant is the same thing as 1 over cosine. So secant squared would be the same thing as 1 over cosine squared. Okay, so here's what I have. So we know that when things like this happen, a cosine squared on the bottom would cancel out a cosine squared on top. So the last thing would just be 1. So that's the most simplified version of that you can get to. So we're using Pythagorean identities, we're using reciprocal identities, and we're trying to simplify as much as possible. This is a tricky concept, so if you don't get it at first, it's fine. You just have to put some work into it and keep practicing. Alright, so let's look at these 3 examples. Notice at the bottom of the page, I just wrote those reciprocal identities out again because we're probably going to be using those. Hint, hint, hint. Okay, so if I'm looking at the first one, I could replace this cotangent with one of the reciprocal identities. So cotangent is the same thing as 1 over tangent. So I'm going to replace that with 1 over tangent. When I do that, notice that I have a tangent on top, a tangent on the bottom. So those could actually cancel out. So on top, I would just have this. Alright. And on bottom, I have cotangent x times the sine of x. On top right here, this looks like a Pythagorean identity, and it is. You just have to manipulate it a little bit. So let me go back here. So we have sine squared x minus 1. If I took this one right here, and I moved this 1 to the other side, I would have sine squared x minus 1 equals negative cosine squared. So I'm going to replace sine squared x minus 1 with negative cosine squared x. Okay, so I replaced that part on top with what I just found. Alright. So now I'm going to use the fact that cotangent is the same thing as 1 over tangent. For instance, I know that tan of x is equal to sine over cosine. And I also know, because cotangent is just tangent flipped over, that cotangent is the same thing as cosine over sine. So I'm going to take this cotangent and I'm going to replace it with this right here. So watch what happens. Okay, so I have this. And then on the bottom, what can cancel out is I have a sine x over sine x. So I have negative cosine squared x over cosine x. So just remember from like simple math concepts, this is like having 2 of these cosine x's on top and then 1 on bottom. So if I canceled out just one of them, I would have negative cosine x left. And that is my most simplified form. So when I say simplified form, I'm talking about just my regular sine, cosine, tangent, or a number like 1 or negative 1. That's what I'm looking for. Alright, let's try the next one. This is difficult. If you're not getting it, just keep going. So let's try the next one. Okay, so for the middle one, anytime there's like a 1 plus a tangent or a 1 plus a cotangent, look at those Pythagorean identities. So I want you to find a Pythagorean identity that would fit here and one that would fit here. So go back to your chart and see if you can figure out what you could replace those with. Okay, so we have a Pythagorean identity that says 1 plus tangent squared is the same thing as secant squared. And then we also have another Pythagorean identity that says 1 plus cotangent squared is the same thing as cosecant squared. Okay. Then we're going to use our reciprocal identities. So secant is the same thing as 1 over cosine. So I'm going to replace secant squared with 1 over cosine squared. On the bottom, cosecant is the same as 1 over sine. So I'm going to replace cosecant squared with 1 over sine squared. So let me rewrite this, what we're doing. So we have 1 over cosine squared x divided by 1 over sine squared x, which is a fraction divided by a fraction, which you never want to happen. So you're going to use same, change, flip. So really what I have is on top, I have sine squared x over, on bottom, cosine squared x. Remember that tangent is the same thing as sine over cosine. So if you had sine squared over cosine squared, this would just equal tangent squared x. That is my most simplified expression. Okay. So now let's do the next one. This one's actually the easiest one we've done. Alright, so on top, this is a Pythagorean identity. Go to your chart, see if you can figure out what it equals. Sine squared plus cosine squared is the same thing as 1. So I can rewrite this as 1 over sine x. And if I look at my reciprocal identities, 1 over sine x is the same thing as cosecant. That's my most simplified answer that I can come up with. Okay, let's do some more. Alright, so if I look at this next one, number 4, this is actually already a Pythagorean identity. And if you can find it, you can replace it. So go look at your Pythagorean identities. Here it is. Secant squared minus tan squared is the same thing as 1. So this answer It's just 1. And sometimes they are that simple. Not all the time, but sometimes. So now look at the next one. You got a trig function squared with a 1. That's probably a Pythagorean identity. Hint, hint, hint. It is. Go find it. See what you can replace that with. It looks very similar to this one right here. So if I were to get secant by itself, I would just add 1. So yeah, I can replace that whole entire thing with secant squared x. So cosine squared x times secant squared x. So now let's rewrite these. So cosine I'm not going to do anything to, but secant is the same thing as 1 over cosine. So I'm going to change this to 1 over cosine squared because it's secant squared. And now hopefully you can see that the top and bottom cancel out, and my answer is just 1 again. It's so nice. Alright. Now this next one looks tricky. It looks complicated, but it's not if I rearrange it. So I know that the main Pythagorean identity says sine squared x plus cosine squared x equals 1. I have that right here. I'm going to rewrite it so you can see it. So what if I just repositioned it? And I know that sine squared plus cosine squared is 1. So I really have 1 plus sine x minus 1. And then 1 minus 1 cancels each other out. So really, I just have sine x. That's my simplified version. Sometimes they're easy. Sometimes they're not. You just have to practice so you get better. Blah, I know. Okay, let me know if you have questions.